Welcome back to Urevise, where we talk about everything exams. Let us take a look at question 39B from the 2016 exam. It reads, pentlandite, which is this compound, is a common nickel sulfide ore that can be used to obtain the materials required to produce sulfuric acid. This metal sulfide ore is combusted in air to form sulfur dioxide according to the following equation. So we can combust this in air to form sulfur dioxide. The sulfur dioxide is then passed over 4 beds of vanadium pentoxide or platinum catalyst at 450 degrees to produce sulfur trioxide, which is this one. And this reaction is exothermic. How do I know? Because delta H is negative. It goes on to say, state 2 justifications for the use of a catalyst in this process. Let's take a quick look at what the examiner had to say here. The examiner says in part B, many candidates simply stated the general role of a catalyst without giving specific justification for this industrial process. The question asked for 2 justification and indicated that stating that a catalyst increases rate of or lowers energy of activation would not gain marks. Okay, now the question is, when I did this in class, my students were asking me, why would this not get me marks? Because if I have my reaction that is occurring with this much activation energy, right, and I add a catalyst which lowers activation energy, why would I do this if I'm not seeing a benefit beyond just lowering activation energy? There must be another benefit beyond me lowering activation energy, because it's a pointless exercise to do something that doesn't actually benefit me or benefit the actual industrial process. So the examiner was expecting you to explain, okay, after the activation energy has been lowered, what is the benefit to this industrial process, rather than just regurgitating the definition, because lowers activation energy by offering an alternative pathway. That's just a definition. Now, let's take a look at the benefits of lowering this. One of the benefits is, remember, if I have to provide this much activation energy compared to providing just a part of that activation energy, this is money I'm saving here. So I could simply say it reduces costs because the reaction, the process, is carried out at lower temperatures Actually, let's just leave it at that. Another benefit here is, instead of waiting for particles to achieve all this much energy, I'm only waiting for particles to achieve a fraction of that initial energy, which means I'm going to see my reactants converting to products much quicker. So the other benefit is the rate of yield increases. So I increase yield by doing that. And then another thing, what else? I'm going to be saving on the energy source that's being used. So I'm going to be using less of the energy source that is being used. Obviously, carrying out a reaction that involves gases like this at a higher temperature carries its own risk. So if I lower the temperature, I'm mitigating those risks involved, because if you look at these are gases, right? And gases at high temperature means high pressure in the real world. So what we're looking at, it makes the production process safer. Okay, this question only required 2 reasons. I've given 4 here. I'm gonna finish off this one at this point, and I shall see you when you attempt the next question. Thank you once again for watching. I shall see you in the next video. I hope this video was very helpful, and I would love to hear any questions, any concerns, or anything that you think could have been done differently in this video.